So today I'm going to be talking about this slogan that we came up with around the Ember 2.0 era called stability without stagnation. And I'll go into a lot of really excruciating detail pretty soon about what it is exactly that I mean by that. But I think it's important to realize that the concept of stability without stagnation is something that, while it might sound like a slogan, is something that people are always looking for an answer for. They talk about things like the innovator's dilemma as a paradox, something that you need to try to find a solution for. And I think the concept of stability without stagnation for Ember is really an attempt for us to try to figure out a solution to that set of problems that people always talk about without going off the rails and doing something that we might regret. When I was starting to work on this talk, one of the things that I realized was that the concept of stability without stagnation actually stands in stark contrast to another meme that exists in the ecosystem, which is move fast and break things. And this meme is not just a meme that exists at Facebook. I have lost, here we go. It's not just a meme that exists at Facebook or existed at Facebook. It's a meme that I think represents one particular way of trying to grapple with the pace of change. So one way of trying to grapple with the fact that things are changing all the time is to say, we don't have time to slow down. We don't have time to think about what we're doing. We just have to break things all the time. Whenever we discover something has happened, we just go off, try another experiment, reboot, start over. Sorry, ecosystem, we can try again. And interestingly, move fast and break things was cool at Facebook for a while, but eventually they had the much less sexy alternative, move fast with stable infrastructure. And when Mark Zuckerberg announced this, he said, it might not be quite as catchy as move fast and break things, but it's how we operate now. What we realized over time, actually, hold on, let me delete something. What we realized over time was that it wasn't helping us to move faster because we had to slow down to fix these bugs, and it wasn't improving our speed. And this is something that I think people notice when they really try to take the other worldview, right? So there's the stability without stagnation worldview, the let's try to figure out, let's throw everything we got at it, let's try to figure out how to deal with the pace of change without having a lot of instability, without causing people to have to rewrite things all the time. So there's this problem that we're grappling with. The alternative is, don't worry about it, you just reboot all the time, it's fine. Eventually, at some point, people realize, actually, no, breaking things all the time, rebooting all the time, that actually isn't really working. Now, there's always new people that could come to believe that that process is going to work, but I think fundamentally Ember, as a project, does not believe that that's the case, and I want to talk a little bit more about that. Before I start, I want to talk about SKYLIGHT, the company that I work at, because another thing that I realized when I was thinking about the Ember stability without stagnation, this whole process that we go through, is that I work on an app a lot called SKYLIGHT. It's a project that I work on. It's a performance monitoring tool for Rails apps. And one of the things that I really love about SKYLIGHT is that I get to go to work every day, mostly not worry about tools, mostly not worry about frameworks, mostly not worry about infrastructure. A lot of that, obviously, is that we're using Ember. It's my framework. But most of the time, and this is like 99% of the time, we get to spend time working on stuff that we care about. And so, for example, here's an example of a blog post that we wrote a little while ago, and it starts off feeling very stodgy. And eventually, if you keep reading this blog post, what you'll realize is that this entire blog post is leading up to what icon should we use to represent how many requests per second or per minute this particular thing is getting. So we spent all this time, I think we spent maybe somewhere between 2 weeks and a month as a company discussing approximately this thing, what icon should we use. That's actually really great. I really love that. It's a thing that makes me feel pride in what I do. It makes me feel like I'm doing something great. But it's something that I only get to do because I don't have to spend all my time working on tools. Another example of this, which is this is also seems pretty silly. So we said, oh, well, we have a problem in our app. We need to allow people to change their names. And I said, wait, I'm pretty sure every single time people bring up names, there's all this whole ball of stuff that you need to think about. But in particular, it seems like first name and last name is not really a thing. Et cetera, et cetera. You should read the blog post to get more information. But if you look at what we ended up doing here, we ended up doing a pretty involved story for name change, right? So it's, come on. Is this somehow my fault? All right. So we did a pretty complicated thing where you type your name, and then it says, can we call you this person? There's other variants of it for all the different things that we do. So here's another example where you say no. If you say no, what that means to us is that we want to allow you to type something, but we actually differentiate between did you say that you wanted your nickname, or did we guess it for you for various reasons? And this blog post goes into a lot of detail about it, and it's pretty cool. But again, this is something that most apps would not even spend any time on. It's like the process of changing your name. And I think we spent, again, something like 2 weeks on this particular UI. And this was something that I really loved going to work and working on. It seems crazy, but I actually liked it a lot. And it was something that we ended up releasing a JavaScript library. We ended up writing a blog post. It was pretty awesome, right? And we actually, probably my favorite thing that came out of this story at the end was we did a thing where we said if you have multiple spaces in your name, we'll assume approximately the American explanation for what foo-bar-baz means as a name. And somebody tweeted at us and he said, actually, that's not valid for like Dutch. And I replied back and I said, that's great. What is, like, is there a heuristic that I can use? He said, actually, yes. It's just like, is it van, whatever? Like, seems great. So we just added that to our thing, right? And that was great. But this is something that most people don't spend a lot of time thinking about. The last example that I'll give, and I won't go into any detail here, is actually doing GitHub OAuth. This is another thing that I think, personally, I find frustrating in a lot of places. Here is Liz Bailey, who works for us, made this cartoon as part of the blog post, basically just to deal with the fact that there's some complexity involved. And sort of what we think as a company is that what we're trying to do is we're trying to deal with all the little things that people normally don't have a lot of time or effort to think about. And I think that, so we've started using the hashtag. And I think that that's great. I think that that's something that I like going to work every day doing. I think it's something that most people would like going every day to work on. And somehow get the process of actually building an awesome product that you spend a lot of time polishing and thinking details about has gotten lost in a wave of the web is changing all the time. I need to innovate. I need to reboot. I need to complexity, simplicity, whatever, right? In the meantime, the thing that we're actually supposed to be doing is building amazing apps for our customers. So this is sort of how I think about what it is that Stability Without Stagnation is doing, is it's building space for me to work on this stuff. Now, if you look at other platforms, if you look at Android or iOS, why is it that people who build Android or iOS apps don't have the same level of frantic panic about change all the time? In fact, the web doesn't change a lot. There's certainly new features, but the web is actually quite compatible compared to iOS or Android. But you don't feel the same level of panic in iOS and Android as you feel on the web. And the reason for that is that iOS and Android have this thing called an SDK. And there's somebody on Android, and there's someone in iOS, and if Windows Phone was still a thing, there would probably be an SDK for that too. There's somebody whose job it is to say, what is the holistic experience of building an application for this platform? And if I want to make some changes to it, let me think about what it means to actually make a change in a way that will not break every app in the world, it will not break every developer in the world. And that's something that is just the status quo of every other platform other than the web. And so a part of what I think Ember's job is Ember's job is to actually do that for the web. Ember's job is to say, there's going to be somebody out there who actually manages the pace of change, the progress of change, that gives you an API that you can use, a set of APIs, a holistic experience, keeps making things better and better and better, but without breaking things all the time. So I think that's what our job is. I want to say a couple of things before I get into the mechanics. I think, in general, instability for us as framework developers, but also you as a user, is a pretty big drag on innovation. I think people think the opposite. They think there's a lot of innovation happening, and the only way I can deal with that innovation is to be unstable a lot, reboot a lot, rethink a lot. And I think that instability in general actually slows people down. It makes it very difficult for people to build things. It creates quicksand where people can't build up. And I think every place where you look at where people are building up, you can build higher and faster on a stable foundation. I think that all this stuff seems very obvious. It seems very pat. It almost sounds cliche. But it really runs counter to a lot of the way that people think about building stuff on the web. So before I continue to go in preaching mode, I want to start by saying Ember actually got the details of this pretty wrong early on. I think early on we fell into the trap of believing the move fast and break things mantra. For example, we thought that if our competitors had a feature we didn't, our users would leave very en masse. And in fact, it was our instability, early on instability, especially in 09 and some parts of the early 1X, that alienated a lot of our early adopters. So we had early adopters that were very excited about Ember, and the fact that we were unstable as long as we were alienated people. We got a bad reputation for it, and people criticized us because they felt burned by Ember. The flip side of us feeling like people will leave if we don't have a feature is that people don't leave anything overnight. They need a reason to leave. And one of the best reasons that you can give someone to leave is things don't work anymore. So you have some time. You don't have infinite time to fix anything, but you have some time to fix things. And you shouldn't panic and freak out and reboot everything all the time because of the fact that you think people are going to leave if you don't do something. In general, new functionality, which is the problem that everyone's talking about, new functionality is not a software problem. It's a distribution problem. The question is not what is the feature. We've had features like app cache and WebSockets, IndexedDB, typed arrays, asm.js for years. And the problem with a lot of these features is not so much a software problem, it's a distribution problem. How do we get the feature in front of new users? So what Ember tried to do to accomplish to deal with this problem, and now I'll just start diving right into the tactics of it. Ember said, well, there's a bunch of different kind of users in the world. There's people who are building apps and want a lot of stability, and there's people who really want new features. And what we'll allow people to do is we'll take a page from Chrome, we'll allow people to opt into either very unstable channel in which there's a lot of experimentation going on, a lot of new features, or we'll allow people to opt into the release build, which is the build that has features only once they're vetted. And the important thing about the release build is that the release build is Semver, right? So that means that once we get through an experiment and actually land it in the release channel, that means that people can rely on it continuing to exist until the next major version. So here is sort of a rough picture of what our process is. If you know the Chrome process, or if you know the Firefox process, or if you know, basically, there's a handful of 6-week release cycle projects out there. Rust is another one. This is pretty familiar. Roughly speaking, there are 3 branches in the world. There's master, and it actually is pretty important for our purposes that master is the place where all feature development happens, right? So we don't do feature development on the release branches, and I'll get into more of the details of how that is managed later. But basically, the way that you think of your job as an Ember developer or Ember contributor is I work on features, I put them on master. Eventually, features move into the beta branch, and eventually, once they're done moving to the beta branch, they make their way into the release branch. That takes place. 6 weeks sounds like a very little time, but actually, between getting the feature through the CANARY branch and through the beta branch and through the release branch, it usually ends up taking somewhere between 12 to 18 weeks from the beginning of a feature to the end of a feature, no matter how simple the feature is. So that actually is interestingly, 6 weeks, again, sounds like blistering pace, and I think this is actually the fastest that you can do when you have to deal with adoption in general, but it actually is a pretty slow process. In order to understand, I'm going to do this a very micro, detailed view of a very, very simple feature. What is it? All the stuff I just said is very abstract. What does it look like to get a simple feature into Ember? So the feature I'm going to look at is called ember-metal ember-assign. And basically what this feature is we used to have a feature called ember.merge. And how many people here have written JavaScript or write JavaScript? Great, awesome. So ES6 has this feature called object.assign. And object.assign just merges some stuff together. It's sort of the standardized version of the jQuery.extend pattern. Ember had a similar version called ember.merge. But we were like, oh, object.assign came out. We should, even though we don't support only browsers that have object.assign, we should probably migrate towards the object.assign pattern. So I'll tell you, spoiler alert, this feature made it into Ember 2.5. So now we'll walk through the process of how that happens. How does it get there? So the first thing that happens is that somebody writes a pull request, and it's always a pull request. No matter if you're a core contributor, it's always a pull request. Someone submitted a pull request to add a feature. So it landed on the master branch. Let's look at what it means for a feature to land on the master branch. So first of all, there's a file in the root of the directory called features.json. And it enumerates all the features that exist and their current status. So when you that should be a plus. I'm going to fix that, because that is going to drive me crazy. So the first thing that you do when you're starting to write a pull request for a new feature, and a new feature is just any feature that adds any public API. So when you start to write a new feature, what you do is you add a new line in feature.json, and you start its status as null, which basically means it is off by default. What this also means is that it will not be automatically included in any beta or release builds just yet, and you have to explicitly opt into them in CANARY. The next thing that you do is add a entry to features.md. This is actually not doing anything except letting people who are interested in knowing what the progress of features are have a nice human-readable list of what's going on, and I like it. The next thing is you have to go implement the feature. So what you can observe is that the feature is actually very easy. But there's a couple things interesting going on here. So first of all, the feature, like I said, is very easy. Second of all, what you can see here is that there's this thing that is a feature flag. Like I said, any new feature that adds public API to Ember always has to come through a feature flag. And what feature flags do is they allow us to automatically, in release and beta builds, remove features that aren't on yet. In release and beta builds, it allows us to remove these conditionals, right, and the falsy branch. And in CANARY, it allows us to dynamically allow you to opt into the feature. We use AST transforms to remove it, so it ends up being quite efficient. And the important thing here is that there's a predictable way for every new user, every new contributor who wants to add a feature to do so. The next thing that this person did, and this was actually not mandatory for this particular feature, but it actually ended up being pretty useful for my talk, is he said, oh, well, we should probably also deprecate ember.merge, because people should not use it anymore. It's actually legacy functionality. What you'll note here is, first of all, there's also the is enabled check. So the deprecation warning also you should not start getting deprecation warnings if there's nothing to move to, right? So make sure to put the deprecation warning behind the flag. You'll notice that the deprecation warning has some extra metadata. It has this ID and until 3.0.0. And of course, we can't break things until major release, so it's always going to be 3.0.0 if it's a breaking change. But this combination of things is actually used by the Ember inspector, which gives you information about what deprecations are happening in your application, coalesces them, things like that. And it's also used by the Deprecation Workflow tool, which is a tool, an add-on that you can install that will allow you to say, I have dealt with all the deprecations for this type. Please make it an error if this deprecation comes back. I don't want it anymore. So there's a whole workflow process that you can use that basically allows you to check things off. Again, the relevant public API changes are guarded by a feature flag. Of course, new features need tests, so tests also go behind the feature flag. This allows our CI to run the entire test suite with and without disabled features. So as people are starting to add features to Ember, the CI system runs the version of it that would happen if we released today to beta, right? So it runs it without any features, and it runs it with all features. In principle, we could run a matrix build with every combination, but that would be very expensive, and so far we have never encountered a situation where it mattered. But occasionally we'll do extra passes if we think that some feature is highly risky. One of the things that's really great about this process is that it causes us, the core contributors and other PR authors, to notice right away if they have broken any in-progress features. So what this basically means is normally what you would do is you would do the work on a feature branch, and there may be 100 other PRs that happen during the time that you're working on them, and every single one of those PRs might actually break your change. Now, in principle, I think people are OK with this. They say, oh, I'll just deal with it. I'll rebase it or whatever. But we're doing a community project here where we have a bunch of people working together. If you put a feature flag in there and somebody submits a PR and CI runs and it turns on the feature flag and they broke your feature flag, that's a good thing for them to know. And this also creates a limited budget for doing a lot of experiments, right? There is actually an integration cost eventually for integrating these features, and being upfront and explicit and amortizing the cost of the integration is a pretty nice thing to make sure that you're under budget in terms of how many experiments you could be running at one time. So in other words, it keeps all of our contributors on the same page about what the work in progress is, but we can still take our time until the feature is ready before shipping it. Again, the functionality is wrapped in a feature flag. And finally, we also test deprecations. And the reason for this is that it's actually pretty common in regression that we have a deprecation warning and somebody refactors something innocently and then they accidentally forgot to call the function that happens to have the deprecation. It can be quite tricky to figure out how to write the deprecation in the first place, right? So it's very easy to do a refactor that happens to lose the deprecation in some scenarios. So we always write tests for the deprecations as well. And in this case, you can see it is also behind a feature flag. So the point of all this is that it's a very small feature. It's actually pretty easy to wrap your head around it as an audience member here. But there's a pretty coherent process for encapsulating all the code that is related to this feature and allowing us to continue to make progress on other features at the same time. There's a bunch of stuff I did not show here, which is that there was a bunch of code, a bunch of changes to make code that was existing already using ember.merge, use ember.assign, and all that got encapsulated quite well as well. So that ended up being pretty nice. So just to recap, what is the benefit of feature flags? So feature flags give you the ability to run CI against all the experiments with flags off, which is the production version of your thing, and flags on, which is the experiments that people are running. It also forces people to get religion very fast about actually getting tests to pass, right? I think one thing that happens a lot of times when people have experimental branches is they'll have red tests forever. But if you make a PR and check it into Ember master and you have a feature flag and the test fails, that's actually a failing build. So you cannot actually submit a PR with a feature flag where you have failing tests because you didn't get around to it yet. Now, disabled features are stripped from beta and release builds. So beta and release builds do not allow you to opt in. This is actually a subtle point, but I think it's important. The point is that people are very, you're dealing with an ecosystem. So there's add-ons that may want to opt into a feature. And users who download an add-on will not necessarily know that that add-on is opting them into a feature. So the idea that you have, oh, people are opting into a level of instability that they are willing to accept. As soon as you allow people to opt into unstable features on the stable channel and allow add-ons to turn those unstable features on, you have basically eliminated any possible benefit you have of people understanding what's going on. And what I usually say to people, if they really, really want unstable features, is we have a channel for that. It's called CANARY. Please use that. And I think there's something very nice about the fact that if you want to use CANARY, if you want unstable features, you know that you're doing it, and it's a sort of coarse-grained message that the whole ecosystem understands. Disable features are included in CANARY. Actually, both branches are included in CANARY, and they can be manually enabled. You can actually run, usually people use CANARY for testing. If you wanted to run CANARY in production for some reason, you could run the same build process that we normally run and go into features.json and change whatever things that you want. But that's pretty rare because of the fact that features make it through the pipeline pretty quickly, and when they're not through yet, they're pretty unstable usually. And then the last point is rejected features. If it turns out, oh, we didn't end up doing that feature, it's actually quite easy to remove that feature because everything is carefully wrapped in a feature flag. You can automate the process. You can even leave the code around because the code doesn't actually get included in the production builds at all. But eventually you want to remove it, and it's pretty easy to do that. So great. So we had this feature. I just showed you effectively the PR for that feature. It landed on master. At this point, the feature is available to CANARY testers, and what's going to happen is some companies and individuals are going to download CANARY for their purposes. Oh, this is a new feature. Let me try it out. They'll try to make some changes. Typically, what will happen is some people will report bugs. You have made a mistake. In this case, that didn't happen because it's a very easy, simple feature. But at this point, if we didn't do anything else, when 2.5 beta came out, it would not be included. In this case, the feature was very simple and there was no complaints. So what happened is some time went by and the core team had a weekly meeting, and we added to our weekly meeting the agenda item of please review this feature. So actually the feature.json gives us a pretty good agenda for every single core meeting. Like, go through it. Are there any null features that should actually be turned on to true? So eventually we noticed the feature, say it seems good, great, we're going to give this feature a go. And so we will basically say feature is a go. At this point, basically nothing interesting happens. There's exactly one thing that happens when we give it a go is that we go into feature.json and we change it from null to true. The only people who will notice anything at this particular point is CANARY testers. The CANARY testers will now see that feature on by default. So if they don't opt into any special flag and they say ember.assign, they will see it. So that's actually great. There's still a possibility that a problem could be detected in beta, so we're not going to remove all the feature flags just yet. So we're just moving things along. Some more time passes, and we're getting ready to branch Ember 2.5 beta from the Ember 2.5 CANARY branch. The first thing that we do is branch the release branch from the previous beta branch. That's uninteresting for the purpose of this story. But the next thing we do is we update the beta branch to master. Because the feature is enabled in the features.json, it will be automatically included in the beta build. I appear to have a duplicate slide. So what that basically means, actually, sorry. So we make it into the beta build. Then some more time passes, and eventually the same exact process repeats, except for the beta process, it's very boring. For the beta process, unless somebody notices, oh my God, something crazy has happened, we need to abort immediately. What usually will happen is it sails through without incident, but the same process repeats. This time we do the merge, gets into 2.5, and great, now the feature's in 2.5, everybody's happy, people install it. So a really nice thing to notice about this whole story is that there wasn't that many steps going on. It definitely is more complicated in some sense than maybe a process that you would be used to, but it's a pretty small and understandable process, and it gives you all the things that I just said, including it is now with very little effort other than the core team saying, yes, we want the feature, and saying true, we got it into 2.5. And if we had decided not to do that, if we had decided it wasn't ready, the exact same steps would have happened, except it would not have landed in the release channel at this point. And I think that's actually pretty nice. So now you know the story of the 3 release channels, and also how our process results in a relatively fairly stable framework, even though we're releasing every 6 weeks. However, over the past year, we learned that while this practically results in a fairly stable and predictable set of changes to the framework itself, not every application can update every 6 weeks. We're not a browser. We can't actually force people to download things, which means that in practice, applications end up on a whole spectrum of versions, and add-on authors have a pretty big difficulty figuring out what versions to support. We, as Ember, have difficulty figuring out what versions to support. So what we ended up doing is we ended up saying, we need to make some changes here. Before I talk about that, I want to say, I think the way most people think about these release channels is that there's effectively a trade-off between how long you want to wait for new features and how much stability you want. And you pick the channel that is at the appropriate place on the axis for you. But Godfrey, who I work with at Tilda, noticed that there's actually, it's not like if you waited 18 weeks or 24 weeks, that would result in more stability, because like I said, once we land on the release channel in Ember, we're locked in, we have Semver, we actually aren't going to break that code anymore. So you're not actually gaining any more stability if you wanted to wait more time. So but there's another axis, which is upgrade cadence. And upgrade cadence is basically how much time do you have to schedule time to upgrade? How much time does the ecosystem have to deal with upgrades? How much time does an add-on author have to upgrade, to deal with some change that happened in Ember, right? So there's this other axis entirely, which is upgrade cadence. And upgrade cadence ends up being a pretty important thing to deal with somehow. So around the time that we were working on Ember 2.0, I wrote this RFC, RFC 56, which is the refining the release process RFC. It's very boring. But one of the things that I talked about in this RFC was the idea of LTS releases. And the important thing to understand about LTS releases is that they're just yet another channel, and I'll show in a second how it fits into the whole picture, that gets updated less frequently than the release channel. So understanding what the problem is that we're trying to solve. I think some people do LTS releases purely in response to some pressure. Someone says, we need LTS releases. Say, OK, seems good. I will give you LTS releases. What we try to do is we try to understand what is the problem that it is that people are having that makes them want LTS releases. And it's some combination of people can't schedule time to upgrade. They're using private APIs they shouldn't be using, right? So there's some combination of things that happens. And once you enumerate them, what you realize is that just treating LTS like another slower channel is pretty good. So we approved RFC on October 2nd, which of course required us to create a new Tomster to represent the LTS channel. And the short version of LTS releases is you get to upgrade less frequently. You get bug fixes for 36 weeks instead of a shorter time frame. You get security fixes for 60 weeks. I think in practice we were doing this already, but it's nice to have an official thing we can say for sure. And every 4th release is LTS, and the first LTS was Ember 2.4. So we decided we're going to do LTS sometime in October, and we eventually did it in 2.4. The basic story here is that the existing release channels allow you to make a trade-off. On CANARY, you get features as quickly as they land, but you get no guarantees about those features. On Stable, you have to wait 12 weeks for features to stabilize and make their way through the beta process, but you're rewarded with Semver guarantees, which is great. And like I said, while this provides all the flexibility you need to make the stability versus features trade-off, there's another dimension, which is how often you can schedule time to upgrade. And LTS releases give the community an alternative schedule. One of the things that's really nice about this is that it's very easy for an add-on author to say, I'm going to support the current version of Ember and maybe N-1 and the last LTS release. And if you are on some other Frankenstein version of Ember, you're on 6 versions old or something, an add-on author could very easily say, please upgrade to the LTS or please downgrade to the LTS. Right? It's very easy for someone to say that. It was very difficult to even understand what that meant before. So having a term which means the thing that people should be on if they're lagging is good. So we now have a 4th release channel. So now we have 4 release channels, and I want to show you how that fits into the diagram. So here's a diagram that I showed you before. You can see We do periodic merging of channels. And like I said before, the only thing that the LTS release does is it creates another slower channel. There's one thing that I did that I feel quite strongly is the correct thing to do, but was pretty counterintuitive and was resisted, which is that we did not release 2.4 LTS at the same time as 2.4.0. We released 2.4 LTS 6 weeks later, just like we released 2.4 6 weeks after 2.4 beta, right? And the reason for this is that LTS people, by definition, are pretty risk averse, and while usually 2.4.0 is a pretty good release, sometimes there's some changes that have to be made to fix some bugs, and I would say half the time there's some 2.4.1, 2.4.2 or something like that that fixes some problem, some regression or something. And in fact, in this case, we had 2.4.0 was an especially bad variant of this, so I'm very happy that we pushed for this. And so the idea is that 2.4.0 is just, it's effectively the beta period for the LTS release that's about to happen. So now that we have LTS, what does that mean for our friendly ember-assign feature? Well, as we saw, it landed on 2.5, which means it didn't make 2.4 LTS. So it will be in 2.8. And that allows you to understand what it means to be on the LTS release, which means you are not going to get this seemingly simple feature. It's basically the trade-off in action. However, it's worth noting that for features like this is a very simple feature that's very self-contained. Members of the core team usually maintain polyfills that work on older versions of Ember. The reason for this is actually not mostly about users who can bring their own load dash or whatever. The reason for it is that add-on authors actually need some way to say, I'm going to target some spectrum of Ember versions, and I don't want to have to write the polyfill myself. So some member of the core team, usually Robert Jackson, writes the polyfill one time, everyone includes it, and then it's really weird for me to say like Ember polyfill, but this is a thing that is actually happening. So Ember, there's going to be a version, an add-on somewhere that says, here's the polyfill for getting ember.assign on older versions of Ember, and that's what will happen for LTS people, right? So if you're on 2.4 LTS and you have an add-on that happens to need ember.assign or wants it, they will pull in the polyfill and everything will be fine. So again, since it wasn't in 2.4, it won't be in 2.4 LTS. I actually really like, in general, the versioning scheme here, which is if I didn't tell you anything and I gave you a few simple rules, it's actually pretty easy to understand that if something landed in 2.5, it will not be in 2.4 LTS, even though it's 6 weeks later. And I think it's easy to understand that if something was in 2.5 beta, it will not be in 2.4.0. I think that versioning scheme works pretty nicely. There's one last thing about LTS releases that I think is pretty important, which is that sometimes in the world, people come to depend on APIs that weren't public. Sometimes it's APIs that are undocumented. Sometimes people intentionally go in and poke into private things. Sometimes people just rely on the timing behavior. That is pretty hard to guarantee. So we have this term in Ember called Intimate API, and what it basically means is it's an API that is not technically covered by Semver, but we basically know if we break it, it's going to break a lot of people. And so even though in principle we could say, we can pull out the Semver rulebook and say that we're happy to change whatever we want, we don't like doing that. The rule used to be that we'll wait 2 releases, we'll deprecate, and then wait 2 releases and then remove it if it's an important thing to change. What we will do now as of the LTS change is that we will not remove a feature in an LTS release unless it was already deprecated in a previous LTS release. And what that basically means is that if something was not deprecated in 2.8.0, it cannot be removed in 2.12, which also means it cannot be removed in any of the intermediate release channel releases. However, if something was deprecated in 2.8.0, it's fair game for it to be removed in 2.9. And the reason for that is that people on 2.9 are, by definition, a little bit less risk averse, and if you need to worry about intimate APIs, you should just stay on the LTS release. It's fine. So now that we talked about a little tiny feature, what about really big features, right? Because the whole point of stability without stagnation is this trade-off between incrementalism and innovator's dilemma, right? So that thing I just showed you is a really great story for incrementalism, but what about bigger features? How do you do bigger features? So the feature I'm going to talk about as a case study here is a feature called engines. And the idea behind engines is if I'm working on an app by myself, SKYLIGHT, we don't really need the amount of code that we write is actually a reasonable amount of code to put into one app, to put into one payload, to put into one team's head. But sometimes you're working at a company that has multiple teams working on multiple parts of your application. And just like those multiple teams do not have as high bandwidth communication across their teams as humans, it's unrealistic to expect them to have high bandwidth communication across their APIs. So the idea behind engines is to say if you happen to have a team structure in your company, you can create an engine, and the engine will ask you to be more explicit about your dependencies on the main app and other services. But in exchange for that, we will basically give you some promises about its isolation characteristics, including ability to lazy load and things like that. So the idea is that it allows people to create multiple teams and not worry about the complexity of multiple applications. The details of that are beyond the scope of this talk. But obviously, this engine's feature is not going to land as a PR that has a small feature flag like the previous feature. So there's another step that we do in Ember, which is called the RFC process. And I mentioned the RFC because I said that I had an RFC about the release planning process. But let's dig a little bit deeper. The story is any significant feature, even if it's being worked on by a member of the core team or a member of a sub-team, has to submit an RFC. This is not lip service. This is not just to make us feel like we're part of the community or whatever. I don't even understand what that means, but that's a thing sometimes happens in open source. It's not just lip service. I actually can't count the number of times I have written an RFC expecting it to be pretty uncontroversial, and then when it got out into the light of day and a bunch of community members and contributors responded, it had to be radically altered. And this was a thing that I probably, if not for the RFC process, would have landed the original version of it in code. Right? So the RFC process is helping us to tap the fact that we have a large number of users, a lot of community members, a lot of contributors who know a lot of different things that we don't know. And it's also very important to make sure that there's broad consensus about the direction of what it is that we're doing as a framework, which is impossible unless the rationale that we use as a core team to make decisions is presented and debated in public. And this is something that the Rust core team worked out like a year ago based on a crazy thing that happened called the Great Int Debate, which was literally a bike shed about what to name ints, and it was very long, many hundreds of comments, and caused us to get religion on the idea that if we want to make a decision, it has to be on the basis of rationale that was already presented and debated in public. And I believe strongly in that idea, and the RFC process sort of enforces that idea. So if you're keeping track, here's what the whole lifecycle looks like. We have the RFC process, we have the CANARY experimental feature, we have the beta build for when we're pretty sure it's ready but want to make sure, release channel, and then LTS for people who want to upgrade at a slower cadence. Before I get into what exactly is in an RFC, I want to give props to the Rust project for basically inventing the exact details of the process that we use. Obviously, RFCs are a very old thing, but the exact details of the process that Ember uses are cargo culted directly from the Rust process, which is great. So what's in an RFC? The original template, like I said, was cribbed directly from Rust. And if you look at the Rust template and the Ember template, you will see that they have these sections in them. A short summary that allows someone to understand roughly what's going on. Motivation, which is attempt to describe use cases. Detailed design, which is supposed to be fairly detailed technical stuff that would allow someone who's implementing it to not have a lot of questions. Of course, there's always some. And then drawbacks and alternatives. I actually really love the drawbacks and alternatives thing, which I would not have come up with on my own if I didn't copy Rust. But the thing is that it's really great to be forced to write down an alternative, even if you think it's a non-starter. A lot of times I'll write down a thing as an alternative that I think, I can easily argue against that. And then I try to write the paragraph that explains why it's a bad idea. And it's like, that's actually pretty hard. And I think that's a good process. I think arguing against things that seem like they're non-starters carefully is actually a good thing to get into the habit of doing. There is one thing that we added to the Rust RFC template that I'm pushing for Rust to adopt, which is a new section called How Do We Teach This, which we recently added. How do we teach this is this. This is the description that you're given in the RFC template, and it's basically what are the names and terminology that you should use? How is this idea best presented? Is it part of an existing Ember pattern, or are you inventing a whole new thing? Do we need to change the guides? Do we need to change the entry documentation? Does it change how Ember is taught to new users? How should this feature be introduced and taught to existing users who already have a worldview, right? And the idea behind this section is basically threefold. First of all, we noticed that the terminology in RFCs actually gets spread pretty far, even if it was just used to help clarify implementation details. So sometimes we'll have written down some implementation detail, and it will suddenly become the name of the feature as far as the community is concerned. And that is in large part because a lot of the participants in RFCs are influencers in the community. So what happens is they don't have any better name to call something. They see a name that's it's actually clarifying. Indeed, that was the point of it. And they go out and start telling basically every user that they should call it. An example of this would be closure actions and stateful helpers, both of which are very, very bad names for those APIs, but ended up being the canonical names that we now have to claw back because of this problem. So that's one thing. Second of all, we felt that the RFC process was doing a pretty good job of helping us maintain control of the technical budget, the technical complexity budget, but it took a lot of work, and often not in the RFC process, to help maintain control of the programming model complexity budget, and making it an explicit part of the process early on helps, especially because a lot of times the people working on the features, like a good number of RFCs are not written by anybody who's going to implement it, or at least may not be anybody who's on the core team. And it's important for somebody who is planning on doing a thing to realize, oh, I am actually changing the programming model, and allow us to discuss that. And then the third part, which is sort of related, is there are a lot of users who don't have enough technical know-how to go dive into the details of an RFC, but actually would be able to reply pretty effectively and usefully to this section. And we were just losing all that feedback until it was way too late, until you already shipped the feature, basically. So this gives users with good knowledge of the programming model, who are good Ember developers, a chance to contribute, and also a chance for us to learn from them, which is, again, usually happens way too late. In this case, the original RFC for engines was written by Tom with some help from me in October 2014. It has to date 199 comments, many of which significantly altered the trajectory of the feature, and it has since been picked up by Dan Gebhardt, and it's been funded by a company to do some of the work. It's a whole saga. It's a multi-year project. Not because the implementation details took a long time, but because indeed sometimes when you write RFCs, it can be a long discussion. That discussion was a very good discussion to have. There's another thing that Rust does that I want to copy for Ember, which is called final comment period. The idea behind this is that not everybody could look at every RFC. Once you're getting ready, once you're getting done, you really would like to be able to say, hey, people who are only tangentially paying attention, please come check it out. And now's a good time to object. It's still pretty early, right? We're only designing now. We're not implementing yet. So if you have any objections, now's a really good time. And it works pretty well in Rust, and I want to adopt it in Ember. Now, interestingly, so I just said a high-level thing about engines, but once an RFC is accepted, it's usually broken up into pieces. In the case of engines, it was broken up into two major pieces. Dan implemented the critical capabilities that we needed to enable the feature in a feature flag called Ember Container Inject Owner, which is as boring as it sounds. But he implemented the part of the API that's meant to be used by the public in an external add-on. And while the feature could, in principle, have been developed behind a feature flag, this allows us to experiment with bigger picture engine questions in a package with its own stability story, not tied to Ember's stability story, but built on top of a stable core that we can ship quickly as part of Ember's compatibility story, right? So what that means is that if you're using an old version of the Ember Engines add-on, it will continue to work with newer versions of Ember because we already shipped the core kernel of the feature that is needed in a stable way. And actually landed in Ember 2.4, which means it will be in the LTS release, right? So you can use basically whatever version of this Engines add-on that you want with any version of Ember after 2.4. Now, interestingly, after the RFC is merged, the process is actually identical to the process we saw before with ember-assign, which is eventually it makes its way through the master process, the beta process, and in fact, in this case, it landed in Ember Container Inject Owner in 2.4.0. There's another feature that you might have heard of called fastboot. Fastboot is also is a thing that allows you to run Ember apps on the server efficiently. You can run many of them concurrently without booting your app many times in Node. And the fastboot feature actually works the same way. We made a core change to Ember called Ember Application Visit, which basically just gave you a public API for booting an application and then visiting it without, and basically being able to visit multiple times. And that feature had to be added to Ember. It landed already. And the other things, Ember CLI Fastboot and Ember Fastboot Server, are external add-ons that, again, have their own stability story. Again, this is a really good idea because it allows us to have a thing that is still somewhat experimental, that exists in the world, that people can try and use, while still being able to benefit from the fact that there is some amount of the feature that is already highly stable and will continue to work, and we promise that that's true. So Ember Application Visit landed in 2.3, and people have been using Fastboot in production already for some time. The thing about the whole 6-week release process, the process I just talked about, is that it's incredibly freeing. One of the things that I felt before I knew about the 6-week release cycle is there was this process where there was a period of time, usually it was a code freeze, and if you didn't get the feature in before then, basically it was not going to get in for a very long time, months or years. And I worked on a lot of apps like this. And what that meant is that as the code freeze is approaching, there's a lot of incentive for people to say, OK, it's very important that we actually push back the code freeze because we need to get these features in. Because if they don't get in, they're not going to get in till later. And that basically means there's a vicious cycle from I need to get the feature in, so you push the thing back, but that increases the scope of things people are trying to get in, and it just gets delayed forever or for a very long time. What I've basically learned is that if you have discipline and stick to the 6-week release cycle and just say, we're just going to do 6 weeks every single time. If something isn't ready, it's not going to make the train. If something's unstable, it's not going to make the train. You can get the next one. If you think something might be dangerous, don't do it, because there's another one coming soon. That is an incredibly freeing thing. It's freeing for maintainers. It's freeing for contributors who know that they don't have to panic and work a weekend just to get some feature, some PR in, because it's not going to get in a certain time. It's really great for the add-on ecosystem because they have a predictable way of understanding what features are being monotonically added to the platform. And it is also really good for end developers who can basically feel like if a feature got in and it didn't work exactly the way I wanted, there's a nice process for incrementally evolving it towards the thing that I want. So basically, we have a way of people opting into the level of stability and release cadence that they want, and everybody has a general understanding that we're moving as fast as we can, but no faster. We're going to move fast, but we're not going to be risky. I have one last story, which is, so I said a bunch of stuff that are within the rubric of what you can imagine people doing in an incrementalist system. Recently, I worked on a project called GLIMMER 2 at EmberConf. I announced it. Let me show you a couple demos. But there's an interesting question here, which is how do you do GLIMMER 2? Rust has a project that it's been working on for a while called MIR, which is a whole new IR system for Rust. How do you do that feature? A lot of people say, well, what you have to do is you have to start over. You have to rewrite. You have to stop the whole team. Everybody take vacation. 3 people will work on the thing. But I don't think that's true. And let me first show you what GLIMMER 2 is, and then I'll explain why. So here's, you may have seen this benchmark. This is the benchmark from last year when we announced GLIMMER in the first place. And the idea is that it's a benchmark that has a bunch of things in it. You can scroll, you see a bunch of things. But then if you actually, and you can, there's a requirement that DOM is stable. But if you hit play, it runs pretty quickly. The version of Ember before GLIMMER 1 was like less than 1 FPS. So this was a very big improvement for this particular benchmark, and we were very proud of it. And GLIMMER 2 has an equivalent version of the same benchmark. And just to be clear, it is running exactly the same code with no code changes. So this is an important part of the GLIMMER 2 story is GLIMMER 2 is a very large change. It's like, if you know Ruby, it's like Yarv, where it was like a complete change, rewrite of the underlying engine. But it is intended that it does not have any effect on your code. Right? So we took exactly the same code that ran 10 FPS last year, and now after GLIMMER 2, which already exists in the world, this is using Ember, like end-to-end Ember. It's twice as fast, which is great. But there's actually a thing that we noticed last year when we did this, which is that we had a pretty big regression in our time to render components. So we made a new benchmark, which is basically just every single box there is a component. And it's basically like, let's try to make a thing that renders a lot of components. React is pretty good at this stuff, so the first thing that we did was we created a React version of a benchmark. This was not actually demoware. This is a thing that we actually did to figure out how to build GLIMMER 2. And this demo was created basically to figure out what the baseline performance is. So again, this is React. It's 20 FPS. That's actually pretty good. There's 1,000 components on the page. 20 FPS for re-rendering 1,000 components over and over again is actually a pretty good deal. You can see that it has the same requirement of being able to hover over things. Now here is the same benchmark running on Ember CANARY today with HTMLBARS, which is the old version of the rendering engine. So this is the version that we shipped last year, basically. So you can see that we're just showing that it is 2-spec. And then I'll scroll up, and benchmarks are funny things. There's a whole song and dance. But you can see it's slower. It actually ramps up. You can see there's some interesting thing like ember-jits OK. But it's not as fast as React. When we did this under control conditions, we got 15-ish FPS, and React got like 20 FPS. So indeed, there is work to be done. Here is the same benchmark running today on CANARY with GLIMMER 2. So this is the GLIMMER 2 engine that, again, there's a feature flag already in Ember. Now you know what feature flags mean. There is a feature flag. You can turn it on, and that is what is running here. You can see it is better. And in fact, it beats React, which is great. So I'm very excited about that. And the cool thing is that this is, people probably don't know Ember, but it's basically an Ember app running a regular Ember component with the regular Ember API and a regular template. It's a thing that could work in Ember 1.13, and it's pretty good. Interestingly, we actually spent a lot of time baking in components into the engine. That's basically the thing that gave us good optimizations, and it actually worked pretty well. dbmon, which is has lower components, got like a 2x speed boost, but Uptime Boxes, the other demo, which is very, very component heavy, got a 3x speed boost to about 40 FPS. So the story of baking components in at a low level works pretty well. So that's Ember. The Glimmer engine is actually a standalone thing that you could download and use. We haven't shipped it as a thing. You have a single JS file yet, but it is actually a standalone thing. This is the code that you can run on regular, like bare Glimmer without any Ember on it. So again, you can see it's pretty much the same code. It doesn't have all the Ember features, but it's pretty equivalent to the feature set. And if you run the same demo, again, we'll do some proof that it's to spec, right? It has the right stuff. And then if I hit play, it's way faster. So there's actually some room to grow here, which is really great. So here's like a picture of the FPS. You can see we're much better than we were. The reason I kept going on Glimmer 2 is because browsers don't let you go faster than 60 FPS if you use request animation frame, and we were not using 100% CPU. So we're like maybe like 70 FPS. So how do we get there? How do we get to the Glimmer 2 story? It's basically object model improvements. There's things in the legacy Ember object model that are not optimal. But basically, the exact same optimizations we did to Glimmer with the exact same backwards compatibility story will work because it's effectively the same data flow model in the object model. We just have to do it. Now, you might have thought that I have pulled a misdirection because I originally talked about initial render being important, and now I didn't talk about it for a while. We didn't forget about initial render performance. It's just harder to make an exciting demo out of it. The first thing that I'll say is that in component-heavy scenarios, Glimmer 2 is between 1.5 and 2x faster. This is basically real examples. LinkedIn gave us a benchmark that is effectively an isolated copy of their app, of a page in their app, and it got anywhere between 1.5 and 2x, depending on the exact demo. So 1.5 to 2x is basically what we get on initial render if there's a lot of components involved. However, what you can see is that we're still not doing so great. We can still do better. So that's still a lot better than where we were. If you run bare Glimmer 2, it's a lot better. It's actually getting to be pretty competitive. And basically the same story is the same story. It's we need to fix the object model. The object model does a lot of stuff that is making initial render slow. And if we get there, we'll probably be in a good competitive space. But there's actually other wins as well. Glimmer 2 templates are about 5 times smaller than HTMLBARS, and they also don't evaluate. They use JSON.parse to construct them. So between the fact that they're much smaller over the wire, that's after minification and gzipping, and the fact that they don't evaluate, there's a big initial render win there. And something that I have been playing with, but I don't have any conclusive story here is a cool thing about Glimmer 2, and you should go watch my talk when it comes online that goes into the technical deep dive of it. But Glimmer 2 is basically a VM. It's basically a opcode VM that compiles your template into opcodes, loops over them, constructs an updating program, and then loops over the updating program. And that particular thing is actually a pretty good fit for very low-level code. And honestly, most of what has been hard about getting asm.js up and running has been designed for games. It's designed for compile your Unity program into asm.js, and I'm trying to figure out how to make it fit well into Glimmer. What I was working on this weekend is having a CPP file in Glimmer, the Glimmer repo, and being able to import it as an ES6 module, and we use TypeScript, so have type feedback and all that stuff, and it's almost done. So it's going to be cool. I think there's a pretty good story once you break down the problems into something that looks a lot more like a traditional programming language. There's a lot of low-level stuff that you can do that is outside of what most people think is the problem. So back to the original point, which is I gave you a pretty good story for how incrementalism works for most things, including engines, which was a big project, took a long time. Basically how we keep going, even though we're not shipping the feature. We have an RFC process. We have feature flags, blah, blah, blah. But Glimmer 2 is really a thing that required 3 months of work outside of the repo to start over, et cetera, et cetera. And I think it's like an important thing to introspect on, but I will say a few things. So first of all, stability means not having to change your apps. So even though Glimmer 2 required a pretty big amount of non-standard for Ember work, it doesn't change the app API, which is good. Second of all, while we were working on Glimmer 2, people were able to keep working on Ember. And almost all the things that they did are pretty interoperable with the Glimmer 2 work we were doing. So we didn't like halt the universe to wait for the Glimmer 2 work to finish. We have as an ethos in the project that we keep going. And in fact, people did a lot of work to make Glimmer 1 faster. And we got like some double-digit, like somewhere between like 20 and 50% improvements on Glimmer 1 just by doing the normal kind of optimization you would do. So I think as a project, we have that ethos. But I think the bigger picture is that once you have a process that explains what it means to do incremental work, it's actually possible to look at a project like Glimmer and say, OK, let's break this project down. What does it take? Well, maybe I could spend like 3 months working on Glimmer, but honestly, if after 3 months I don't have something to show for myself, this is not going to work. We're going to get into a new normal rut where people can't make any progress. So we better get to an ending point very fast. We better start integrating it into Ember pretty fast. We better have a feature flag. Maybe the feature flag doesn't let you do a lot, but we better have feature flags. And the feature flags better be making sure that other people are not regressing Glimmer in the meantime. Right? We better make sure that our tests run against HTMLBARS and Glimmer at the same time, because if we do that, then we can make sure that then we can make sure that we don't, while we're working on one thing, regress the other thing, or vice versa. Right? So the same process that works well for simpler things works well for bigger things. You just have to figure out how to break them down, and it's not magic. You can't suddenly break down a 3-month irreducible problem into very small increments, but it is possible to use the same model to reason about whether you're going off the rails or not, whether you have exceeded your budget. And my personal opinion is that something in the realm of 3 to 6 months, 6 is really pushing it, is acceptable for totally parallel work that doesn't slow down the project otherwise. But at some point, after like 6 months, you enter into like Perl 6 territory where you have now entered new normal, where it's like, OK, now everyone's just waiting. And once people start noticing that they're waiting, you can't reboot from that. So if you want to do a project like Glimmer 2, I think it's pretty important that you still try to figure out how to map it into the same model that works well for other kind of progress. But it's also important to note that we did it. Right? So the idea that you can't do it is wrong. So a couple wrapping up points, almost out of time. What about breakage? So I talked a lot about not breaking things. Of course, we're not the web, so we can break things from time to time. What is our process for breaking things? So first of all, the higher order bit is Semver. I say Semver taken seriously, which basically means Semver and we don't bump the major version every 5 minutes. Right? I think our general plan is to bump it somewhere between 12 and 24 months with a bumping schedule that is based on how many changes we're making and how fast the ecosystem could process them. So some people take Semver, the fact that you're allowed to break if you bump, as a license to just bump and break, and we don't. We say Semver tells us what the rules are, but it doesn't actually tell us a lot about the physics of the situation, which is that people cannot absorb that many changes. So we do Semver, but we also don't bump that much. Whenever we deprecate something, we always deprecate to something else. So we deprecate a feature, and we tell you, here's the thing to do. That's a requirement for deprecating something. There's a lot of stuff we haven't deprecated simply because we don't have a really good story for what to do next. And there's always a deprecation guide that is linked to from the deprecation notice and the tools that help you do that. We try really hard to do rewriting. We first try to do like internal AST rewriting that we can do ourselves without involving you at all. Sometimes we write tools. We generally find that stuff doesn't work as well as you think for various reasons, including code-based churn and other things that people don't think a lot about when they first think that this is a great plan. But I mean, it's basically all of the above strategy. So if external rewriting will help get the job done for some particular change, we'll do that. The deprecation workflow add-on is really awesome. A lot of people use it basically to effectively pin themselves to, I don't want to use any features older than this, and I want an exception. And then they use it to checklist down features that they want to remove. And it's really important for us that we successfully deprecate things if we want to remove them. I think if you say we're deprecating this feature and still a lot of people use it, it is not actually acceptable to remove it. So the idea behind deprecation for us is not just we're deprecating it as a warning, we're deprecating it and we take seriously the responsibility of getting people off of the feature. And that's a lot of this other stuff. And then intimate APIs is just another version of the same thing, which is people are actually using features. That means that their add-ons will break. That means their apps will break. We could pretend that we're allowed to do whatever we want. We could throw the rule book at them, but it doesn't. That's not right. It's not morally wrong. Maybe you can make an argument for being morally right. It just doesn't work. right? People actually are using the APIs, and they will just stop using your product. They'll go use something else. They'll get upset. They will start becoming a dissident on your RFC threads, right? So gotta be nice. I also want to say that we learned from 1.13 that 1.13 we did too much breaking, and I think we know that now. And our acceptable tolerance for breakage is basically like 1% of, or like 5% of whatever we did in 1.13. We're also the first 6-week release cycle project ever that did any breaking change. So I think somebody has to figure it out. But there's low tolerance for breaking changes. So to wrap up, stability without stagnation, it sounds like a slogan. It actually isn't. It's a very detailed and involved process that you have to buy into, and once you do it, it basically works. Once you do it, you're not thinking about it a lot, and you get to spend a lot of your time working on your, the framework or your app. It helps you avoid getting stuck in a local maximum without wildly stabbing in the dark looking for some improvements, which creates ecosystem churn and breaks apps. It takes a while for ecosystems to get humming, to move. You can't really afford to reboot all the time because the ecosystems can't recover as quickly as you think. Repeating what I said earlier on, I think instability in general is a drag on innovation. I think if we think we want to build innovative apps, I think SKYLIGHT is an innovative app. If we want to build innovative apps, we actually have to have something stable to stand on in order to do that. And I would encourage people to think about innovation in terms of their own apps, in terms of the things that they're building every day, being proud of your job, not am I using WebSockets. SKYLIGHT uses WebSockets. It's great. It's awesome. But that's not an important part of what it means to innovate in SKYLIGHT. So really what Ember wants to do is be more than a DOM library or the V and MVC or something like that. We want to build a foundation together that will make it fun and fulfilling to build web applications. I personally have 2 hats. I work on Ember as a framework, and I think about all this stuff, and then I go work on SKYLIGHT, and I want to turn off the part of my brain that has to care about any of this, because I have to spend time thinking about when someone types in their name in a box, what do they mean? And that's actually very complicated, and if I have to think about whether I'm using WebSockets or not, I will not succeed. I think Ember wants to be something that builds a foundation that makes it fun and fulfilling to build web applications that you like building, that you like going to work every day building. And I think that's a good thing to exist. So thank you.